Okay, here we're supposed to find a formula to find this limit and actually go ahead and reduce it and actually really find the limit. This one was a little tricky, I thought, because if you work it out the normal way, you end up with kind of a mess. And if you look at the book solution, you're kind of going, what are they doing here? So they're they're kind of thinking a little bit about the formula, and they're kind of making some changes to it before they actually get into working it out. And so I'm going to explain to you what the book solutions do. And you could still work it the other way, but you kind of end up with a mess at the end that you don't know how to deal with, which is why they showed you this way in the solution key to work it. It's because it doesn't work out really nicely. Okay, so I've got this limit. The problem, I've got this I minus 1 squared. Well, I could go ahead and do this by multiplying out the I minus 1 times I minus 1. And you'd get I squared minus 2I plus 1. And I could, just split this one little sum, sigma, into 3 different ones. But again, if you do that, you end up with a mess at the end. And you're like, why do I have such a mess? Well, sometimes they'll give you problems and they'll kind of give you a hint on how to get started. Here they really didn't, but then when you go look at what they did, they should have. We're going to see this in the next section as well, that sometimes they're going to give us a hint and be a little more helpful. So here's what they're doing here. They're going to take the limit as n approaches infinity of this, but just for now, let me work on this piece right here. And what I'm going to do is I'm going to rewrite it. Here's the rewrite. What if, since it's I minus 1 squared here, what if I just went to I squared? What if I adjust my boundaries? That might be an easier thing to do. For instance, instead of going from 1 to n, why don't we go to 1 to n minus 1? Now, how would that help me? Well, if I go from 1 to n minus 1, I can just write this as I squared. So again, this is I changed the n to an n minus 1. So instead of going to I minus 1 and then squaring it, I'll let that I just go up to n minus 1 and square it. I'll simplify the formula into I squared. Now, this is going to mean we need to be a little careful. So if I'm copying my formula in, and this time I'm going from 1 to n minus 1, the formula says for I squared, if I just write it as I squared instead of I minus 1 squared, it's kind of like if I were going up to, I were going to have x minus 1 squared and I were going to plug in 4, why don't I just make it x squared and plug in 3 is the idea behind this, which might be hard for you to see. You might have to think about that a little bit. Again, this would not be one I would put on a test, but it's definitely one we can learn something from. Okay, so if I do the I squared formula, that is like n, whatever that is, times times n, let's see, plus 1, and I'm leaving this out on purpose. I'm not putting my n's in on purpose, because remember, what I'm going to plug it as an n minus 1, not an n. They're playing a game here. Times 2n, which is going to be, I'm going to plug in a different thing there, plus 1, plus 1. All over 6. Okay, so what I'm really going to do here, instead of putting the n in, it usually goes up from 1 to n, but it's going up from 1 to n minus 1. So this needs to be an n minus 1 here. Okay, so there's going to be an n minus 1 there. It didn't fit. I'll have to put it in there. And this is going to be n minus 1 plus 1. And I'll simplify all this in a minute. And this is going to, again, instead of putting in an n, I'm putting in an n minus 1 so that I can have a simpler formula to evaluate. The math works out so much better this way. You can try it the other way, and you'll kind of see what I'm talking about. You get to the bottom, and you get a mess, and you're not quite sure what to do, and you could do something called the dividing out technique, but it just seems a little hokey. All right, so I've got the sum, I equal 1 to n minus 1. Actually, I already plugged in. I can get rid of the sum because I've substituted the formulas in. So now I'm just simplifying the formula. So this is n minus 1. Now n minus 1 plus 1 is an n. And then 2n, and then if I distribute this, this is going to be 2n minus 2 plus 1. Well, 2n minus 2 plus 1 would be 2n minus 1. So if you're looking at the solution key, you're like, what did they just do here? And this is what they did. They just changed it. Instead of I minus 1 squared, we'll make it I squared. So instead of going to n, we'll just go up to n minus 1. We'll play a little math switchy outy thing there. All right, so now I have to simplify all this. This is, remember, that's a 6 on the bottom. And oops, I forgot to keep up with my 1 over n cubed. So again, let me write that out front because I'm going to have to go back and stick that in. I got so concerned with this I minus 1 squared that I forgot to keep up with my 1 over n cubed. And it's going to be multiplied by everybody here. Okay, so we've got this far. Let me go ahead and get a new page. Let's see, new page. So I'm just going to pick up in the step where I left off. If you look, we've got that now. We've got 6 over n cubed. No, I'm sorry. It's on the bottom. On the bottom, we have 6n cubed, if we multiply that all out. And now we have n minus 1 times n. I'm going to rearrange this stuff. Here's what we've got. I'm going to put that solo n out front, and then I have an n minus 1, and then I have a 2n minus 1. Okay, so I got to multiply all this out. Now, n times n is n squared, so that's going to be n squared minus n. I'm going to go ahead and multiply those two together. N squared minus n times 2n minus 1 all over 6n cubed. Everybody's going to get that eventually, but I'm trying to simplify the expression now. So that's going to be 2n cubed minus n squared minus another 2n squared. That's going to be minus 3n squared. And then negative n times a negative 1 would be a plus n. And all that's over 6n cubed. So now I'm going to split my fractions up. Let me go ahead and say, let's go ahead and do the limit now as I split the fraction up. Let me go ahead and start writing that in now because I really do need to, again, we can keep up with it separately and then just add it in here at the bottom. That's going to be 2n cubed, that's 3, over 6n cubed, minus 3n squared over 6n cubed, plus n over 6n cubed. Okay, so if we start reducing these fractions, that's going to be, those are going to cancel out. I'm going to have 1/3. So that's going to be the limit as n approaches infinity of 1/3. And then this is going to reduce down to 1 over 2. But let's see, there's 2 n's on top and 3 on the bottom. So I would just end up with the n on the bottom. So that's going to be minus, let's see, that was a 1 over 2n when we got done. And then that last fraction, there's, 1n on the top. So that's going to cancel out with 1 on the bottom. So it's going to be 1 over 6n squared. So now I'm ready to evaluate the limit. Now when I evaluate the limit of 1/3, no matter what, is a third. And then this minus 1 over 2n, when I plug in infinity down here, that's going to approach 0. So that's going to be 0. And then if you plug in, infinity down here and square it, multiply it by 6, this whole thing's going to approach 0. And so your answer ends up being a third. So again, if you do it the other way, you're going to get it at the end and you're going to go, oh my gosh, if I evaluate this limit, I've got infinity. Well, then in one of the terms. And so you'd have to do a dividing out technique. So this actually takes care of that with more finesse. And so that's why they're trying to actually get you to see in this problem that you can adjust some things if you're careful and you're doing the right thing mathematically.